Let's get started on Module 5, Part 2. In this section, we will discuss distributed virtual switches, but let's just do a brief review of standard virtual switches. Let's use the vSphere web client to view standard virtual switches. If I use the vSphere web client and I go to the home page and I click on hosts and clusters, I can see here is my ESXi host. If I click on the manage tab, I can see here is my virtual switch. You can see the virtual switch is connected to a physical network interface card, which of course is connected to a physical switch, and that the virtual switch is also connected to a port group, and that port group contains several virtual machines. If I click on Edit Settings and I select Security, I can see that I could configure promiscuous mode if I was using a protocol analyzer. I could configure traffic shaping to prevent one virtual machine from taking all the bandwidth away from other virtual machines. And I could configure network interface card teaming, which provides both fault tolerance and load distribution, all of which we discussed in the previous section. Now let's discuss the limitations of standard virtual switches. The limitations is that you must configure them one at a time. And this can be pretty labor intensive, especially if you have a very large number of ESXi hosts. And furthermore, in order for vMotion to work, you have to make sure that all of the virtual switches on all of the ESXi hosts are all configured the same. And the more ESXi hosts you have, the more difficult that is to do. So the solution is to use a distributed virtual switch. A distributed virtual switch is centrally configured. You configure it once, and then it configures all the virtual switches on all of the ESXi hosts at the same time. It saves you the trouble of having to configure them one at a time. And also it provides consistent virtual switch configuration, which is required for vMotion, which we talk about later. Here is a comparison of standard virtual switches to distributed virtual switches, and you can see that the distributed virtual switch does everything that the standard virtual switch does and more. Now, the standard virtual switch can do traffic shaping, can do bandwidth throttling, but only for outbound traffic. But a distributed virtual switch can do traffic shaping for outbound and inbound traffic. It supports other features, but the main feature that it supports is data center level management, meaning it's configured centrally. So let's create a distributed virtual switch. Now note, a distributed virtual switch requires that you have vCenter server. So to create a distributed virtual switch, we create the switch, then we add ESXi hosts, we create port groups, we configure the port groups, and then we add virtual machines to the port groups. So let's do it. I go to the vSphere web client to the home page, and then I click on networking. And then under VM network, you can see that's the standard switch, but we're not here for standard switches. We're here for virtual switches. I right-click on Data Center 1 and I select Distributed Virtual Switch, followed by New Distributed Virtual Switch. And then I will give it a name such as DV Switch 1, followed by Next. Then, if I wanted to, I could configure it for backward compatibility with older ESXi hosts, but since we are using the latest version, which is version 6, we will select the latest version, followed by Next. Then we specify the number of potential uplinks on each ESXi host. We're not going to need 4, but we'll leave it at 4. I/O control we will enable, and under create default port group, let's deselect. Let's clear that checkbox for create default port group because I just want to create the virtual switch first, then we'll go back and do the port group. I click on next, and it says it's going to create the distributed virtual switch. I click on finish, and there is my distributed virtual switch. What is a distributed virtual switch? A distributed virtual switch acts as a single virtual switch across associated hosts. This allows virtual machines to maintain consistent network configuration. Look at the next paragraph. Distributed virtual network configuration consists of 3 parts. The first part takes place at the data center level where the distributed virtual switches are created, and that's what we just did. And the hosts and distributed port groups are added, and that's what we're going to do next. The second part takes place at the host level where the host ports and networking services are associated with the distributed virtual switch. And the third part takes place at the virtual machine level where the virtual machine network interface cards are connected to the distributed virtual switch port groups. So let's now create, we've already created the distributed virtual switch, now let's create a new port group. So we click on related objects, and under distributed port groups there are none, so we've got to create one. So we click on the shortcut that says create a new distributed port group, and I will give it a name such as dport group 1, followed by next. And then instead of assigning it 120 virtual ports, I will select ephemeral. And ephemeral, it means temporary. What it really means is it's just one day. But that means the virtual ports are created when the virtual machines are turned on. Under VLAN, we already talked about VLAN, so I'm not going to modify that. And under the checkbox that says Customize, I will click on the checkbox that says Customize Default Policies. And now you can see the familiar security settings. Under Security Settings, we could enable Promiscuous Mode. Under Traffic Shaping, we could enable traffic shaping also called bandwidth throttling. Under network interface card teaming and failover, we could configure it for fault tolerance or redundancy. Under monitoring, we could enable net flow, which is a program that measures the traffic on the virtual switch. Under miscellaneous, we could block all ports, but I certainly don't want to do that. And under any additional settings, essentially it shows that we don't have any features enabled here. We'll do it later, traffic shaping, for example. But the only thing that's allowed is that all ports are open. We click on Next. We click on Finish. And now you can see we have created a new distributed port group, which is associated with that distributed virtual switch. And the next thing to do is to add ESXi hosts. So let's do it. I go to the distributed virtual switch and I right click and I select Add and Manage Hosts. Then I click on the green plus button for Add Hosts, and I will add 2 ESXi hosts followed by OK. And then I click on Next. I select the checkbox that says Manage Physical Adapters, and that will allow me to add physical network adapters to the distributed switch. I will click on the checkbox that says Manage VM Kernel Adapters, and that will allow me to add or migrate VM kernel network adapters to the distributed switch. And I will also click on the checkbox that says Migrate Virtual Machine Network, and that will allow me to migrate the virtual machine network adapters that were assigned to the old standard switch. 3 variables to configure. So I click on Next. And now you can see I have 2 ESXi hosts, and each ESXi host has 2 network interface cards, and I want to use them all. So I got to select them one at a time. I go to the first network interface card and I select Assign Uplink. I then select Auto Assign followed by OK. I then select the second network interface card in the first ESXi host, and I select Assign Uplink followed by OK. Then I go to the next ESXi host and I select the network interface card followed by Assign Uplink and Auto Assign and OK. And then I select the last network interface card and assign it to the uplink followed by OK. So now that I've indicated that I want to use all network interface cards in both ESXi hosts, then I click on Next. Then we see that we can manage the VMware kernel adapters. This allows us to manage and assign VM kernel adapters to the distributed switch. Well, I want to assign both of them. So I will select the first VM kernel adapter and the second VM kernel adapter, and then click on Assign to Port Group. There's the only port group that I can select, so I select it followed by OK. And then we see Analyze Impact. And under Analyze Impact, there is no negative impact for the production network or for the iSCSI network or for any networks. And then the next item here, number 7, is Migrate Virtual Machine Networking. And these are virtual machines that are currently on the standard virtual switch. So I want to migrate them to the distributed virtual switch. So I highlight them and I click on Assign to Port Group. I select the port group followed by OK. So now that you can see, we have added 2 ESXi hosts, we've added 2 virtual machines, and there are 2 network interface cards per ESXi host. Click on Finish. And now you can see that we have created our distributed virtual switch with a port group associated with that distributed virtual switch. If I click on Related Objects, we can see that these hosts are associated with this virtual switch. And if I select the port group, I can see that these virtual machines are associated with this port group. Now let's look at moving a virtual machine from a standard virtual switch to a distributed virtual switch. So what we do is we edit the virtual machine settings. So I go into Host and Clusters and I select the virtual machine that I want to migrate from the standard switch to the virtual distributed switch. I right click. This one is called Database Server 1, and I select Edit Settings. Then under Network Adapter, I select the drop down, and it's already selected the default VM network. Well, I select the new distributed port group that I just created, which is associated with that distributed virtual switch, and I click on OK and OK. And then if I go back home and I go into networking, I can now see that this virtual machine has now been added to this distributed port group. Now let's look at editing a distributed port group. And the point here is that any changes that we make to the distributed port group will apply to multiple virtual machines running on multiple virtual switches running on multiple ESXi hosts. So here we go. I have a virtual and I select my distributed port group, and then I click on Manage, and then here you can see the security policies. And I will click on Edit to edit the distributed port group settings. I click on Edit. Now, if I click on Traffic Shaping, you can see that traffic shaping is not currently figured. So what I want to do is enable traffic shaping. I want to limit the average bandwidth to 100 megabits per second, but allow a peak bandwidth of 1 gigabit per second, but only for a limited period of time. And we already did that on the standard virtual switch. But now on the distributed virtual switch, we can now configure egress outgoing traffic shaping. So I can enable that, and I can configure it so the average bandwidth is 100 megabits per second and the peak bandwidth is a gigabit per second, but only for a limited period of time. So changes that we make to a distributed virtual port group, such as bandwidth throttling or security or network interface card teaming, the point is they are applied to multiple virtual machines, to multiple virtual switches on multiple ESXi hosts. Centralized configuration. Distributed virtual switch summary. Whereas standard virtual switches must be configured one at a time, which can be awfully time consuming if you have a large number of ESXi hosts, distributed virtual switches are centrally configured. You can, in one action, configure a large number of virtual switches on a large number of ESXi hosts at the same time. This provides consistent ESXi configuration, and it also provides us with several additional features such as ingress as well as egress bandwidth throttling. Module 5, Summary. In summary, in this module we discussed standard virtual switches, and we configured standard virtual switch policies. And then we looked at distributed virtual switches. And this concludes Module 5. Thank you very much, and have a nice day.